Now we welcome Dr. D. Surendran, PhD in Information Communication Engineering from Anna University, Chennai, CEO and founder of SKS Skills Fasteners Private Limited, with 25 years of teaching experience. His areas of expertise include digital transformation, startup mentoring, upskilling, and soft skills. He holds 2 patents and 70 plus publications and has addressed over 300 professional events. Sir, we now invite you to conduct today's session.
Very good evening, dear participants. Am I audible?
Yes, sir.
Okay. So, at this outset, it gives me immense pleasure to join this session. Hope my screen is visible. Okay. So, today's session, we're going to discuss about digital twin for SDG-based urban transformation. So, more of the things, if you want to know how many slides I have, maybe they're curious because 3 hours at a stretch in the evening after a working day, I know. So I have only 21 slides, maybe 22 slides. And I don't think I to my level best, I don't go to. Most of the things I'll try to create some kind of interest in this topic. Things are going fine, I think. The previous session was also fine. So we'll start with the topic digital twin for SDG-based urban transformation. Now, before beginning this particular topic, this digital twin or metaverse kind of stuff have been talked more since 2020, so almost 5 years down the line. And it's a new and upcoming or budding technology. It is how we were talking when Steve Jobs in earlier 90s was talking about smartphones. So people are really not in the what you say. They're not able to visualize how it will be able to visualize. So now we'll start with this digital twin. So more specifically, I'll start from this Environmental Systems Research Institute in Corporation. This video, more specifically, so what's a digital twin, or more specifically, how we will understand this digital twin? That will be more space for us to get into the glimpse of ideologies and understanding. Now, the thing is, if we have a physical thing, we are just going to create a virtual thing of it. So that is what you mean by a twin, or more specifically a duplicate. We call them as a duplicate. Is more specifically thinking that or more will talk about something called as metaverse. I'll just show you a video to understand metaverse. So that will be first hand for you to get an idea about what is this twins. So more specifically, when you're just going to talk about what do you mean by a digital twin? So everyone is using Google Maps. So everyone is using Google Maps. So this Google Map is a twin of the transportation. So here, this is specifically to my home location. It is in Coimbatore. So here, the physical town Coimbatore in this particular locality, we call it as Jain Mills or Tudiyalur. It's physically there. And this Google Map is created a virtual stuff of the same thing. So here we can see the exact ideology, more specifically with the places, terrains, roads, buildings. More specifically, we have the street view and kind of things. Now, In other ways, what happens is, now here this is only the map and view of things, new specific business parts and malls kind of stuff in education institutions. Now, what happens if we're just going to create entire city or entire country kind of stuff? So that is where we talk about the digital twins. So the digital twin is first trying to understand to first understanding. So now for that, like we'll go with this video. So here in this idea, like we are just going to talk about this digital twin more specifically. So ideologically, I told you a digital twin is a replica or a duplicate of the physical stuff. So here, I just copy that particular keyframe. So here, the digital twin is here is showing a picture. So what is the difference is in Google Maps, we get the 2D. Now we are going to 3D. So what happens if a city, a physical city is shown in 3D? So this is one example. So here, we go to the definition of a digital twin. So a digital twin is a fully functioning digital replica of the built world, including physical objects, relationships, and behaviors, unique by definition. So it's more like a physical property. More we call it as physical property kind of stuff. Like we have a building, we have complexes, we have a city, kind of all stuffs put together. So here, so we have been looking into 2Ds. Now we are just going to talk about 3Ds. More specifically, this is the history of digital twin. In 1970, when US, the NASA was voyaging to the space, the space test was called as Apollo 13. So in 1970, they built a simulation kind of the spaceship, and that was called as the first twin. In 2002, the phrase digital twin is coined. Now, again, it is the same stuff, which can be applied to anything and everything. So here is where the understanding of digital twin comes into the picture. Now, to get to realize this digital twin, more specifically, let me talk about a few technologies, or more specifically, how to build a digital twin, why we need to have a digital twin kind of stuff. Now here, this is an intersection of AR, VR, XR. We call them as extended reality, virtual reality, and augmented reality. It is forming a subset of all these things. Now, more specifically, the fundamental concept here is that if supposing we have a digital twin, how we are able to access or go through this particular digital twin. So that is one way to understand these things. Am I going fine? Is it okay? Is visible? Is audio is clear? Everything is fine?
Yes, sir. Clear, sir.
Yes, sir. Yes, sir.
Thank you. So here, so this is the idea. So let me just go to that video. I just talk about this meta. So this all things happened in this page. Like I'll come to that. Like so here it was in 2002 we started idealizing about how to create digital twins. So here this is one particular place in Arctic Circle. So this a person is like Eri. He is just going to talk about this digital thing. So more specifically, let me talk about this ESRI first. This ESRI. This ESRI is one pioneer in building this digital twin. So this is Environmental Systems Research Institute. Now, this is the pioneering body who build digital twins. So they are into building up the digital twins. So here they give off an a walkthrough of building into the twins. So it all talks about pixels, how we talk with taking the videos and pixels and how they are converted into. This is a 2D picture. So that's again the two things. It's a movie that's called as Last Eyes. So it is in National Geographic Channel. So here here the thing is that when we want to build a digital twin, to understand here is that we need to understand very clearly about the physical object. So only then you'll be able to get into the virtual object. So the very first understanding is that like here GPS or GIS is very fundamental for the digital twin. So, or we call technology called as sonar, radar, lidar. These are all the technologies. Now, converting the case that like when in previous generations, we are talking about more specifically your physical maps. We used to look the maps in Atlas for places and kind of stuff. Now, what happens is then we understood that world is globe. It's a global shape. Then we made the globe, and now when digital thing comes into the picture, we have converted again into 2D. So what we see in the Google Maps is a 2D. So what we see again is a 2D of the 3D dimension. So now earlier we had a software called as Google Earth. The Google Earth is exactly a digital twin of your world. So this is again exactly a digital twin of the world. So here, to understand a digital twin is we are just going to build a physical object, a place, city, or a museum or monument, a forest, anything. It's into a three-dimensional. That is what you mean by a digital twin. So, having given about an idea about digital twin, I was looking for that video for Omniverse. So that will be a very fantastic explanation. Sorry, so give me 2 minutes. I'll just like get back again that particular video. So that'll be very easy for to understand. So The thing is, having understood uh, that can give you an idea. So, okay, so we don't waste time. Like I'll come back later. So, digital twin can be built using techniques called gathering the physical location, latitude, longitude, terrains, kind of things, and visualizing the same thing and making them as physical as it is. So this is the LIDAR data, and most of the cases, many of the places in the earth across the globe are undiscovered. So that we go for satellite imaging. Now here, this is the LIDAR data and analytics. There are 7 undiscovered settlements in Colombia. So still not able to be discovered. So it is not like because it is like destructions in the dark forests, like where the sunlight cannot penetrate. So here there is a limitation of the little points. So here we are just going to create the groundwater. So here this is called a Ciudad Perida in Colombia. So, and the thing is that it will look like one that is here, as you say, the Google Street view is captured by a camera fitted vehicle and takes the pictures. Likewise, to cover the areas which are not able to be covered by satellite. So here, this was the picture. 1 second. So this was the picture earlier. So this one. So this is the picture. I mean, so this is much like consider that a Google Street View car. So here this is altitude air. So this kind of helicopter is fitted with kind of sophisticated imaging devices. So that can deep penetrate in the forest and terrains which were not covered by satellites. So here, the thing is like, so this is where like to find the cameras to get the data acquisitions, right? So this is called as LIDAR rotisserie. So now, so here it is that with this, like they're just going to go through this, the picture where humans have not went into, or more specifically not having idea about how these pictures have been born, kind of stuff. So here maybe in volcanoes and under oceans. So all these things here. So this is the thing. So this is photorealistic replica of the historic discovery. So the first lake in state Halumia crater in the modern history revealed by a phase 1 100 MP camera. So 100 megapixel camera. So the thing is like this gives a first-hand idea about capturing or data acquisition. So before going to create the digital twin, you need to understand, or try to understand, like if just going to create a picture or duplicate, you need to create the trace of things. So now this is what is the understanding of going to create the what do you call the trace. So this is one thing. So here, this is one thing of a volcano and the cave. So here is a case like how they have created a volcano and how they are going to create the twin of a volcano. So here is where they first get the points and how they are made the model, and then they are just going to get the model. So this is the physical stuff, and these are the points and the captured videos, and then they're going to create the twin. So here, taking the videos and then the points and acquiring the data and then mapping them into 2Ds and 3Ds. So here, this is a continuous real-time monitoring. So here is here it creates, like it says, the reality capture will be visual backbone of the immersive experience. Here the real and virtual worlds will be indistinguishable. Increased use of AI in every way imaginable. 3D models will be a mix of photorealistic procedural imagery. A sense of place will add emotion to the digital twin. A new level of cybersecurity concerns. So these are all the predictions of the digital twins, the creation of the digital twins. So here, before going to understand, like, see, this person is wearing an goggle, a VR goggle. So to navigate through the digital twin, we need to have these goggles. We're just going to move into the AR space. Now, so this is one understanding to understand about your digital things. Your digital things cannot be directly accessed through your mobile phones or through your browsers. So you need to have your goggles. So your 3D VR goggles. So only with the goggles we'll be able to go through the pictures. So here the volcano is converted into an a model. So here this volcano is converted into a model. So then, like, it is shown as it is exactly. So now understand, like, to get to study the volcano, it is not possible to do it in the real time. But with this kind of digital twins, so it is possible to create the twins and go to look into the scientific explorations and details of how it is done and kind of stuffs. So here is first idea of a digital twin and how a digital twin is created. So here is an idea about the twin. So now I come back to this presentation. So now coming to the real world examples of digital twins, or going to the types of digital twins. So these are the different types of digital twins. So here it's a virtual mode of a real world system, process, or objects. It's developed by simulating, tracking, and analyzing the behavior, operations, and performance of the physical equivalent using real-time data and sophisticated modeling approaches. So one point, building a digital twin is very, very, very data intensive, research intensive, and compute intensive. So in essence, digital software, digital twin software, I later come to the softwares that are used to create digital twins. They replicate the physical asset in a virtual setting, giving companies information on how it functions, performs, and any problems. So there are 4 types of digital twins: a process digital twin, a system digital twin, a component digital twin, and a product digital twin. So we see each one of them briefly. The process twins, the superior digital twins, combine system twins into a single entity. Now, this is a system, and they take one particular process out of the system. So, therefore, it enables a far more in-depth and flexible output examination. So, this process twins help in adjust inputs without disruption, test predictions risk-free, and monitors the key process indicators. So, for instance, a process twin could simulate every aspect of a product, even down on the workers running the machinery and production line. In contrast, a system twin might simulate a manufacturing process. So, try to understand, like, we are just going to create a submarine. We are just going to create a new spacecraft. Now, in the spacecraft, within the engine of the spacecraft, there is a process, fuel injection or your lubrication systems, circulation systems, and they have a process of fuel injection. So you want to create the twin of the process, the specific process alone. So that is called as your process digital twin. The system or the unit digital twin. System twins are copies of assets that show how multiple components come together to form functioning components at the system level. So here they are combining the processes and the subsystems together. So they provide a comprehensive view of how a detailed perspective of the entire plant or the manufacturing facility. Here they bring a particular manufacturing unit. The asset group focus cover a group of assets performing specific functions such as primary product manufacturing or energy delivery. And coming to advanced capabilities, go beyond detecting errors and breakdowns, providing continuous tracking and modeling for deeper insights, and provide strategic decision making. So this is your system or unit digital twin. The third one is asset or the product digital twin. So product or asset digital twin is a digital replica of tangible assets such as machinery, building, and automobiles, even cities. It offers updated information on the assets, atmosphere, performance, metrics, and functional health. So a product digital twin, the characteristics are integration of component twins. Now here I have components, asset, or products, and they combine the multiple component twins or their data to model complex assets like engines, pumps, or buildings. Do the performance analysis, examine how components function as an integrated unit, identifying areas for optimization. And it gives you enhanced efficiency. It helps engineers identify improvement opportunities, reducing downtime, and improving operational effectiveness, and providing strategic insights. So the valuable operational data, aiding in better equipment management and business innovations. So it is like getting to understand a company called as Kaiser. They are providing compressed air solution. The next one is your component of the part digital twin. So the most basic type of digital twin is the component twin or the parts twin. It is equivalent to the simplest component of the system, such as particular piece of machinery or product like sensor, switch, or wall. So the component twin has the following features like function monitoring. We need to look into the sophisticated parts that have a functionality and they're tracked. For example, a sensor or a switch or a wall or a diode kind of things or a virtual circuit, anything. And for the performance assessment, evaluate reliability, durability, and effectiveness to ensure optimal operation, and simplified factory representation. So part level digital twins offer a basic resemblance to the factory architecture for focused monitoring. So then enhanced maintenance, enable better equipment component monitoring, ensuring timely maintenance and reducing downtime, and operational reliability. So guarantee the consistent manufacturing operations and maintain the quality of the final products. So having defined what is a digital twin and what are the different types of digital twins, and coming into the one type of digital twin, and now we go into this how this digital twin is created. For that, we look into one particular. Before that, I'll talk about a digital twin consortium. Like there are few number of players who are into the creation of the digital twins. So then we have your digital twin consortium. So everyone, when you have a group of a standard kind of stuff. So here you want to have a digital twin consortium. So this is called as DTC. So this executes on the promise of digital twins and associated technologies by working closely with the members to accelerate the market. So here, when we take your World Wide Web, we have your World Wide Web Consortium. When we take your mobile technology, we have your ETSI or ERSI, the Mobile Telephone Providers Associations. Likewise, when you just go to create digital twin, so we have something called as digital twin consortium. So this is the overview. So this is what is the functions of a digital twin innovation consortium. So they are formed by members who are joining in this particular initiative. So here, these are the working groups of the digital twin. So assuming this digital twin should have standards, protocols, tools, industry-specific applications, a platform where everyone who are into the space will be collaborating. So here, in this digital twin consortium, there are working groups. So these are the digital twin working groups. So one is so these many are there. We'll glimpse into each. So one is AI joint working group. Second one is digital engineering group. The third one is financial technology group. And the next one is, it talks like academic and research, aerospace and defense, agriculture, food and beverage, architecture, engineering, construction and operations, AI joint working group, digital engineering, financial technology, healthcare and life sciences, manufacturing, mobility and transformations, natural resources, pharma and regulatory, security and trustworthiness, and telecommunications. So these are the different groups they are working into. So more specifically, they provide collaboration, knowledge sharing, and innovation by the horizontal use cases and vertical industry applications, where these digital twins are used and which particular industry the applications are. Then to develop the standards and interoperability. Later we'll talk about the standard, which are this and kind of stuff, like and different softwares that are used to create digital twins. So creating recommendations and advocating for standards and best practices to ensure digital twins can communicate and work seamlessly across different platforms and systems. Third one is data modeling, simulation, and analytics, focusing on the data structure, modeling techniques, and analytic methods used to create and analyze digital twins. And whenever such kind of things that are available in public or more specifically able to be understood, we need to have to address the privacy and security. So here, we need to address the concerns related to the security and privacy of data within the digital twin system. And technology innovation, exploring innovative solutions and technology breakthroughs in areas such as AI that advance digital twin capabilities. So I've briefed about this digital twin consortium. Now, these are all the things. So here we look into the digital twin capabilities periodic table. So here they talk about the various user guides and the capabilities, and more specifically, so they are into these kind of what do you call the previous case we talked about the horizontal areas. First one is data services. Second one is integration. The third one is intelligence. The third one is the fourth one is UX. The next one is management, and next one is the trustworthiness. They have created specifications for each of these things. So the blue one talks about data services. This yellow one talks about integration, and this one talks about UX, and this talks about the security and trustworthiness. So this is called as a digital twin periodic table. So this is talking about the what do you call the standard to create your digital twin more specifically. So we can just go on look into each one of the things more specifically. So this is the thing in a broader image. Right, so again we download and then coming to how to create the digital twins using your open source. So so these are all some of the publicly available protocols. So this is called as a UA Cloud Twin, a cloud-based digital twin definition language, and OPC UA and UA Cloud UR, a tool used in industrial IoT scenarios to bridge the gap from OT to IT. Then Unreal Pixel Streaming example, a sample project demonstrating how to set up Unreal render streaming. Unreal is a software. Later I'll come to the softwares that are used to create the digital twins. And next one is IoT Edge OCPP central system. So this is your open charge point protocol. That's a protocol. So then EcoCafe, excuse me. EcoCafe Industry 4.0 public, which includes projects for ERP, SCADA, and SysML to describe, execute, and improve end-to-end manufacturing and digitizations. So the DTC's Digital Twin open source initiative encourages digital twin innovation, accelerates digital twin adoption, drives collaboration among digital twin technologies, architects, end users, and vendors. So getting to know about the glossary of the digital twins. So there are few technical terms. So we call them as the glossaries. So here, these are the things which gives you a clear idea about what you mean by, earlier I was talking about asset and aggregation kind of stuff. So we are just going to get that particular glossary here. So what does mean by an application? What do you mean by twin? So all these things will be given here. So a digital twin is implemented in a digital twin system. You have a digital twin system. So this is the system that is used to create a digital twin. So here, as we seen all these layers, it's given in stack form. So this is the IT or OT platform, and this is the virtual representation. This is the security, trust, and governance, and this is the integration service interfaces, and here it is the application. So this particular dotted orange box is your digital twin system. So here, this is the real world, and this is the twin, and here we collect data of the real world, put into the data sources, and we get the real world synchronization mechanisms. Like here, the real object needs to be exactly supplemented with the virtual object. So we need to create this synchronization. So these are all the digital twin system. So having seen what do you mean by digital twin and how a digital twin, briefly, want of time, I swiftly went into the things. This is how you create a digital twin system. So this is a digital twin system. So this is a digital twin platform. So a digital twin platform is a set of services, applications, digital twin systems that are designed to be implemented digital twin systems. So here, the virtual, not physically existing such, but may be made by software to appear this one. So we have Google's definition of a virtual because it captures the intent of a digital twin to allow one to virtually interact with the portion of reality which actually directly interacting with it. So here, virtual is very important. The intent of the term virtual representation was to convey a digital artifact that serves as a virtual replica of the real world or the virtual world. So it is based on the modeling perspectives and the representation. So here we call them as the virtual twin. So here, the resources, these are all your publications related to digital twin consortium. So what of this, each of these things, what are the things that are available, and it is available for all the members. So these are about the digital twin, and looking into the success stories. So here is the ESRI, NEC Corporation, EDX Technologies, Desal Systems. These are all the persons of the members of digital twin consortium members. They were working with these things and creating the twins in their particular space. So here we talked about this digital twin consortium. Now we go to the digital twin software. So we look into the digital twin software. So a digital twin software is a cutting-edge technology that creates a virtual representation of physical assets, systems, or processes. Engineers, urban planners, manufacturers, and a myriad of other professionals use it to simulate, monitor, and analyze real-world scenarios in a digital environment. By doing so, they can anticipate potential issues, test solutions, and streamline operations, ensuring optimal performance in the real world. So the first one is your PTC ThinkWorks. So this is for rapid IoT application development. Next one is the Bentley iTwin. So it is for infrastructure project insights. ANSYS Twin Builder, best for multi-domain system modeling. Aviva, the best for industrial asset management. IBM Maximo Asset Monitor, it is best for asset health insights. Similia by Dassault Systems, best for multi-physics simulation capabilities. Azure Digital Twins, best for scalability with digital integration. So each of the link is given. We can just go and see. Altair SmartWorks, best for adaptive AI analytics. Synto Cloud, best for detailed point cloud integration. GE Digital Twin software. So these are all some few of the 10 best digital twin softwares as of the SaaS team. Now, I just Google and go to the digital twin software. Or now, see, all these things are shown here, and more specifically, the left out are your AWS IoT, and then the Bentley systems. So these are the things that are tipped out. Now I'll change this. So here we get a different list of tools. So the Siemens Digital Twin is a digital prototyping offering from Siemens. MathWorks provides digital twins, how to create models. And then here, Autodesk provides digital twins. I'm talking about Metaverse and Omniverse. So NVIDIA is one pioneer. This NVIDIA uses Omniverse. Omniverse is the platform. I'll just go to NVIDIA Omniverse. Now, here is an example of a digital twin. So here, this is the digital twin. So understand. So this is your digital twin. So here is the idea of a digital twin. To get into the digital twin, you want to have your VR goggles. Without the VR goggles, it is not possible for us to get into a things. Here, so having so for that only, I just like went to that to get to know about how a twin will look like. So only with your goggles you will be able to enter into the twin and have a feel into the twin. Now, with this, like here, we can create a twin of ourselves. We can create an avatar. Now here in this picture, you can see this is Zuckerberg, and this is the digital twin of Zuckerberg. So this is one asset. We call them as the twin of Zuckerberg. So the thing is that try to understand, we can create duplicates or mimics or twins of anything and everything. So this is the idea. Is it clear?
Yes, sir.
Yes. Okay. So now here is where the whole new picture of coming to the pictures like still yet to evolve. Here, because to get to view these things, we need to have your VR goggles. The VR goggles are not yet standardized. And then that needs to be, and we need to, if you want to go to creating these digital twins and using them, we need to have a greater bandwidth, because these assets and streamings of large images need to be done in real time. So data speeds of 5G are very, very essential. So that is where, like, still it is in the form of adaptation. There are various, what do you call, stumbles behind this adaptation. Now, we'll come back to the real world examples of digital twin cities. Now, I'm coming back to the topic. So, the topic is your digital twins for SDG based urban transformation. Now, I need to talk about urban transformations. How this is going to convert a city, we call them as a city, or how that can be used to do the simulations. Now, these are the top 7 real world examples of digital twin cities. So first one is Singapore, the power of virtual planning. So they have created a twin of Singapore. They are leading in the world in the development of digital twin technology. So this digital twin, which is called as a virtual Singapore, is more than simply a model. It's a dynamic data-driven platform that aids the city's decision making. So because they are able to create real-time simulations, they are able to like foresee disasters and plan for the disaster management, and they want to create the environmental monitoring. Now, let me tell you in another way. It's kind of, you need to put it down. Every one of us has a CCTV cameras in our home, right? We have a CCTV cameras. Whenever out of the home, we will be able to open the camera and see that what happens. The same thing here. What is the thing here is that try to understand a twin is how it is different is. Try to understand, I am converting my home into a digital twin, and the physical parameters in the house will be same reflected in my virtual twin also. So try to understand, like if supposing say that I am here, real time I have my BP and temperature and pulse monitored, the same way it is monitored. So then for environmental monitoring, urban planners prioritize sustainability and use the twin to monitor and cut carbon emissions. Second one is Helsinki in Germany, sustainability through virtual models. So they use a digital twin. Using real-time data, Helsinki's digital twin creates a virtual version of the city to aid in sustainability and urban planning. So here they use to monitor the air quality, to get to know the use of the energy and to optimize the energy. So to develop methods to minimize waste and boost efficiency by modeling energy usage patterns. And citizen engagements. Through online resources, individual can engage with the digital twin, studying city project and offering input. Next one is the Shanghai Smart City Transformation in China. So if a city has unparalleled accuracy in planning infrastructure, predicting traffic congestion, and optimizing energy use. Now, most of the cases, we do a simulation. Either it is in MATLAB or NS2 kind of things, any of the tools. Now, try to understand this digital twin here at a higher level. You're going to create a real-time twin, a virtual of a physical item or an industry or a city or asset at home. So with its cutting-edge digital twin technology, Shanghai is accomplishing to convert the virtual Shanghai. So how it is used in Shanghai? They use the Shanghai digital twin to work with the traffic management. So the predictive analytics and real-time monitoring assist in easing traffic and boosting the effectiveness of public transportation. Energy optimization again, disaster preparedness, and infrastructure planning. So suppose they're just going to create roads, they're just going to create metro projects, or they're just going to, in case of a disaster like rain kind of things, they want to harvest your rainwaters, getting tapped the wind energy kind of stuff. Then comes your India's Amravati, the India's first digital twin city. So it is Amravati in the state of Telangana. So this is the capital of Andhra Pradesh, India. So this is unique, is that like the Amravati digital twins, they go for preemptive planning to identify most effective configurations. Planners might use digital twin to model different road networks, layouts, and zoning possibilities. So before going to develop a road kind of stuff, they put it in a digital twin, simulate it and see how it works, and then physically go to the structure. Sustainable development. So whenever I do the planning of things, I don't want to run out of green zones and blue zones. So I don't want to cut down the trees. I don't want to cut down the forest, the greens. And by the way, if your water bodies are there, I don't want to affect the water bodies also. So that has also been, it's what we mean by sustainable development and optimized thing. Next one is your Rotterdam flood management. That city of Rotterdam is it's a complex water system. So here, whenever you have a city that is very prone to what you call flood kind of stuffs, so we can create a dam or a river and its twin. The real current speed, water level, the rise in the water level, the dam's performance, the canals, etc. Everything can be converted into digital twin. So managing flood hazards while maintaining urban growth is one of the Rotterdam's most significant difficulty. So for that, they have created a digital twin of the Rotterdam. So here, that digital twin is used to perform the flood risk analysis, infrastructure resilience, how the drainage systems and how the dam is going to be stronger, how it is performing, and planning for climate scenarios. The city experiments with long-term plans to adjust shifting climate trends and increasing sea levels. So emergency preparedness, in case we have your hurricanes, like cyclones, tsunamis, and how we are just going to prepare for the emergency preparedness. And coming to Korea, the Seoul SMAP. So this is the digital twin of the Seoul. They are again using it for traffic management, urban planning, and providing better public services and citizen engagement. So these are like things. So millions of everyday commuters have found their lives more manageable because of the Seoul's SMAP, which has helped cut average travel time to 15%. Now, try to understand this this Google map in a modified form. If supposing you're in a city, say Chennai or Kolkata or Mumbai or Bangalore, and you have a digital twin of Mumbai or Bangalore, you can directly at real time can see the traffic and the rain, supposing rain pour in some place or wind in some place, or if you have a shopping mall and how crowded it is in the shopping mall, then you can avoid and you can go for the next one. So this is one. So next one is Stalin. So this is Estonia capital Tallinn is accompanying precisely by utilizing digital twin to transform urban planning and developments. Tallinn's use of digital twin technology. So they developed for infrastructure and environment to create 3D virtual city model. So here that the features of this city twin is it is providing enhanced construction projects. So before construction begins, planners use the model to test construction concepts, forecast results, and reduce errors. Effective permitting procedures. If supposing you have a city where we have regulations say that this many stories need to be built, the soil strength and the bearing capacity of the soil, etc. So that needs to be enforced. And for sustainable development, environmental data is employed to ensure the buildings comply with the environmentally friendly objectives. The public involvement, whoever the stakeholders or the enforcing body, they can also be involved. So here the projects are shortened by 20% cut in budget and time. So these are the real world things of the digital twins. So these are the core concepts. I told you I've come clearly and just come to this thing. So here this is the digital layer smart city. This is the data and the information from here. This goes in a cycle, and using your tools, as I told you, we can create a virtual data layer twin. And this is used to aggregate, analyze, and insight the data and analytics and actions with the sensors to control the city. So this is the thing. So the data layers combine terrain, buildings, infrastructure, mobility, IoT, and environmental data into multi-layered models. And what functionality it provides is it enables simulation, scenario testing, decision making, public engagement, and urban resilience planning. So here it is: create, interact, aggregate, analyze, insight, and decisions. This is a cycle. So again, the thing is like here is a picture. It says the layers. So here we are using the data ingestion. It's using IoT sensors and maps, visualization and stakeholder interfaces. We present a layer breakdown using Gluon model graphic. Integration and storage using simulation engine and analytics AI. Mention the perception enabled model, 3D, usually in VR, visual perspectives, etc. So this is picture is given as architectures. So this I've shown in more specifically. Again, we have in real world applications, we have the EU destination Earth. It's called as Destin E, a digital twin of Earth aimed at modeling climate change by European Union. And Sydney case study, a digital twin of Australian city called Sydney. So the real-time and historic data, traffic, emissions, weather, crime, etc. And Bologna, so a citizen-centric model that simulates the social dynamics and co-designs, urban mobility and development with civic stakeholders to improve planning and participation. So New Zealand, Auckland has a safe swim, a real-time digital twin of storm water and wastewater networks monitoring water quality across 84 beaches. It leverages over 1 billion data points daily, now extended to over the broader Northland region. In South Africa, the Pretoria, a digital twin for waste management, citizen engaged mapping, real-time monitoring, generation, simulations, and route optimization using open source tools. Over 1,000 waste containers mapped in 3 days. Then Dubai, Neom, and Riyadh, Middle East. Ambitious urban digital twin project geared towards smart governance, urban planning optimization, infrastructure monitoring, and emergency preparedness. The challenges around data privacy, integration, and governance. So that in hope you remember when you're talking about the digital twin consortium, I've been talking about the safety, or more specifically the privacy kind of stuff, where you need to have secure mechanisms to give authorized access to the stakeholders of accessing the digital twins. Sydney, a data-rich urban twin integrating weather, crime, emission, and traffic data, enables spatial ranking, predictive modeling for traffic, crash risks, and more informed urban planning. So, India-specific initiatives, Amravati I already told. Another one is Varanasi, the 3D urban spatial twin. It is powered by Lidl. Launched to map 160 square kilometer city. This model supports flood risk prediction and disaster relief planning using 75 thematic layers. So estimated about 6 crores. The Amravati digital twin proposed scheme for digital credentials of citizens to access services, improve engagement, and support testing of urban initiatives. Chennai smart city relevant integration, though not a full digital twin. The smart mobility, energy, and environment projects like rapid traffic control and green infrastructure offer fertile terrain for twin integration. So, with this data and kind of stuff, converting into a digital twin is a simple step. Now, coming to the smart mobility and data integration, now we are coming into a point where it is possible to have a mobility as a service. So, this is it showcases the meta cities. Here it is the flexible transport services, connected autonomous vehicles, shared autonomous vehicles, and free flooding e-mobility. In this particular smart mobility as a service, or mobility as a service, it is the demand responsive transport, intelligent transport system, autonomous vehicles, and shared transports and electric. So this provides its role in enabling real-time urban mobility planning and management. So this is one smart mobility and data integration. So now looking into the statistics about digital twins kind of stuff and digital twin market size globally and India. So the smart city digital twin market size is $6.2 million by 2024, and it is projected to reach by $70.6 billion by 2023. So the cumulative annual growth rate is 32.7% annually. So this is one huge area where more leverage can be done. By 2025, over 500 cities are expected to adopt digital twin technologies. Urban heat island reduction by approximately 28% through simulated cooling strategies. 70% of city digital twins are updated with real-time data every 5 minutes. 43% of applications focus on waste and resource management. 88% of municipalities see digital twins as essential for climate resilience planning. Now, try to understand this as a modified form of your surveillance. Now, everywhere we do with cameras and control rooms, we are monitoring. Instead, if you have a twin and with AR and VR gadgets, it is possible for us to have an immersive experience of going and traveling to that particular spot in the city at the real time and see how it works. So coming to the challenges, data governance and privacy. Now, I had to say, as you have seen, we need to have the standards in place and how the data is governed and how this data are going to be handled securely. So integration requires transparency. Failures in Toronto and Portland digital twins stress the need for robust frameworks. More specifically, when you're talking about now, we do the Google Meet virtual conferencing. assume a case that like in my place, my network connectivity goes and there is a power cut. Totally gone. I'm not be able to do this particular session. So likewise, everywhere, every technology has a limitation, more specifically basic to mid to higher level, prone to technological, social, economical, and geo or linguistic kind of stuff, limitations. First one is data governance and privacy. So, and how these twins will be integrated. And then technology and interoperability. So, if say there are 5 or 6 vendors who are going to create digital twins of their own, and if that the one digital twin needs to interoperate and communicate with another digital twin. So, the cross-agency data sharing and standards are essential. And next one is capacity building. Once you have created the twins, we need to train the people and the personnel and the city officials or the persons who take the decisions. And that is what you mean by capacity building. In the Smart City Varanasi project, they train the officials who are using digital twin. It is it's very key to effective use. Because every now and then, whenever there is a technology shift, even when we're talking about AI, the greatest hurdle or choking point here is that whatever may be the strength and benefits and power of the AI tools and things, if you are unaware of using it, if you are not sure about how to use it, then it is again a mere waste. So we need to build the capacity building and equity and inclusion. So because as I told you, the major bottleneck or the choking point here with this adoption of more specifically omniverse, metaverse, and digital twin is higher bandwidth. Now the goggles are costing near about 20,000 or 30,000. The goggle needs to be affordable, and more specifically, they are not that seamless and easy to use. And it should be affordable by everyone. So the affordability and when we want everyone to be included and everyone to use them, so that's what you mean by equity and inclusion. So must ensure accessibility, especially in contexts like regeneration and pro-post strategies. So this is the challenges and governance companies of using a digital lens for the smart urban development. So coming to the applications and impact, more specifically, this is endless. When you're talking about these kind of technologies, it is limited by your creativity. When we are talking about if it is possible to model a city, then there is a definite possibility of modeling a planet. We are talking about space voyages, like modeling Mars, like voyaging to Mars, voyaging to Jupiter, kind of things. So that is another plane. Then what are the applications and what are the impacts of the digital twins? So the climate resilience and disaster management. So it's used in flood predictions, Varanasi and Lisbon, heat mitigation, air pollution modeling. And coming to our mobility and traffic efficiency, Los Angeles, London, and Florence examples reduce congestion and emissions. So they are piloted and they are to some extent solving them. And in the plane of energy optimization, solar potential and energy grid balance in Klagenfurt, so in Amsterdam and Singapore, are done using your digital twins. And in the plane of public engagement and governance, the Florence project's open tools, Bologna civics co-design, and Snap for Cities transparency, they all provide an access to the public to involve and to engage. And it is used to do the governance efficiently and smartly. Then SDG monitoring and reporting, Fisherman's Bend, the SDG benchmarking, it is aligned to SDG 11. So now here, what are all the SDG goals that are benefited or can be profited or more lucrative to be leveraged by the digital twins? So number 3, number 7, number 9, number 11, number 13, and number 17. So SDG 3 is good health. So a digital twin can help you better air pollution predictions, mapping, and interventions to prevent or to stop the air pollution. Clean energy. So there's SDG 7. That's the Claflin's solar potential analysis. Coming to SDG 9. So resilient infrastructure. So that is an example like Varanasi flood modeling, Florence real-time monitoring. That is also an example that is falling under SDG 9. And coming to SDG 11, sustainable cities like virtual Singapore, foresting, etc. So they are sustainable cities, come under SDG 11. It does under SDG 11. And SDG 13 is your climate resilience. Sydney and EU destined for forecasting. That's for your climate resilience. Even your Auckland beach is also for SDG 13. And for SDG 17, it's partnership and governance. So the Bolognans, civic co-design and Amini engagement. So now with this case, the authorities are creating the digital twin and the public is engaging with the digital twin. Not only the public or the control mechanisms, the enforcing people, the real-time analytics, whoever is responsible for the proper functioning and monitoring everything. So that the partnership and governance of SDG 7 is also addressed, right? Scope and the future trends. What are the scope and future trends in the digital twins for urban management? So they span city level to planetary scales, as I told you, integrating data across infrastructure, environment, mobility, and civic behavior. We can see metaverse cities. We call them as metaverse cities. Interconnected urban ecosystems combining physical, digital, and human layers beyond isolated city models. It's put forward by World Economic Forum. Then civic twins, emphasizing social dynamics and citizen co-design, as seen in Bologna Arvids. Then planet scale twins, that is Destination Earth, integrating global environment and socio-economic modeling. AI-driven predictive analytics, so enhanced machine learning models for traffic risks, heat mapping, resource allocation, and open and participative platforms. It is public, open access twins, encouraging citizen-led innovations. Like here, it is not necessary, and we need to always wait for the government or the NGOs or the CSRs to take a step. Even a public can, with the amenable open source tools and kind of stuff, power of creating twins, a public can well participate by creating the twins and giving it for the aid of the all walks and stakeholders. And governance and privacy is a long way to go. So there should be a growing focus on secure, transparent data frameworks, because everywhere every now and then in news, with the apprehensive and exponential growth of communication and devices and digital inclusions, more and more there are possibilities of vulnerabilities and attacks and security tamperings. So we need to be more agile and informed about privacy and the governance, about creating country level or continent level or global level governance, and how these things are managed and what legal regularities needs to be done. So that is one area of this scope and future trend. So the recommended next step is start with pilot project focused on critical SDG areas very specifically. Next one is establish open architecture and governance frameworks for transparency. Suppose if you are adapting for proprietary software kind of steps and proprietary tools kind of steps, that doesn't create your participation or cooperation. That creates silos. That like it is not possible for the other partners to communicate and share their things. So the open architecture and frameworks adaptability is very, very important, and to provide this transparency. Integrate citizen engagement tools for co-design and awareness. One side might maybe the governance and the authorities building. The other type, parallelly, citizens can also engage by parallel integration and working hand in hand with it, and promote interoperability across sectors like energy, mobility, and environment. And it's very important to set your key performance indicators and to track the KPIs. The track KPIs aligned with SDGs targets and measure impact over time. So these are the recommendations and next steps. So in conclusion, so with thoughtful implementation and governance, digital twin technology is a game changer for future cities. Urban digital twins offer powerful means to transform cities, sustainability and resiliency. The integration with SDGs can support smarter planning, stronger climate adaptation, and inclusive decision making. Hope I've given a glimpse, a first-hand idea about what is a digital twin and how it can help, and here and there things about how a digital twin is created, what are the tools, frameworks, the layers, how a digital twin system will look like. So all these things in my available stipulated time, I was able to swift through. So that's all I'm done with. And if there are any queries, I'll be happy to engage, interact. Thank you. Thanks for Study World, the department, for giving me an opportunity for the ACT FDP. And this, as I have a protocol, as a ritual, and saying that, like, I always dedicate my sessions to all my teachers. What I have uttered is all because of the parents and teachers who has taught me to share the knowledge and the informations. Thank you.
Thank you, sir. Actually, it's a very nice session. We had a really a good session, sir.
Oh, if I'd like to hear from the participants if they have any doubt.
Sure, sir.
Kind of things.
Dear participants, if you have any queries, you can open to ask. Sir, actually, I have a doubt, sir.
Please, ma'am. Please.
Sir, digital twin is a broad area, sir. In that, any specific things we can use it for our research purpose, sir? Since
as I told, that's why I told you that, like, here, like, as I told you, the challenges is like in our what do you call the limitations, we can work on kind of problems in it, or if you have any specific intervention or all. Suppose if you have a data tampering, and how we can create your assets and how we can safely handle them. Because as I told you, the problem with this digital twin technology is that you need to have a GPU, or you need to have an Omniverse, a costly tool for 3D building and simulation. So for that, we can work on the problem areas where we can. As I told you, on the security perspective, or more specifically, if it is possible for you to make a digital twin accessible in a lower bandwidth. As I told you, bandwidth is again one choking point where it is an limitation for accessing the twin.
Yes, sir.
In a lower level.
Yes, if I'm having any research thing, Abdina, I can take a problem statement of my research work and I can work as a.
Yes, very well, ma'am. Actually, as I told you, like, is that like whenever you do your normal simulation, whatever may be a thing you do a normal simulation, this is try to understand. That is why I told you there are two scenarios I used to insist on. First one is your Google map. Second one is your CCTV cameras. They are 2D, ma'am. So real time you cannot control. You can see only, right?
Yes, sir.
So with digital twin, what happens is that, like, you create the digital twin, the real stuff is there, real object is there, and digital twin is also there, and you can simultaneously exist in the physical and virtual.
Okay, okay, sir.
So that is why is the key thing to understand it. There are a lot of protocols, standards. It's a long way to go
Yes, sir.
because 5G is bare minimum and VR is bare minimum.
Okay, sir.
There are a lot of platforms where we have digital twin platforms. There is called as Digital Ocean. There is a project by Google where they have an idea that everyone can create twins and they can swell and they can rent the digital twins online.
Okay, sir. Okay.
So try to understand, you have a Brookfield Mall, a Phoenix
sir.
Mall kind of sense. You create a digital Phoenix Mall and rent to the stakeholders. Hope I'm to some extent clarify the idea of.
Yes, sir. Sure, sir. Yes, sir. Participants, is anyone having doubts or any clarifications?
Sir, good evening, sir.
Oh, very good evening, sir.
So what are the advantages of the digital twin over MATLAB-based simulation, sir?
Sir, exactly as I told you, MATLAB is also providing digital twins, sir. MATLAB simulations are 2D, or more specifically, you cannot say, try to understand that in a 2D or 3D, you cannot, if supposing that is what I told you, said, if you are just going to create a submarine, you are just going to create an aircraft. With digital twin, with VR, on the digital twin, with the VR, you can walk into the submarine. You can walk into the spaceship and see it.
Oh, okay, sir.
That is why I told you that this is the 3D extension of the simulation.
Okay, sir. Okay, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Participants, do you have any questions?
I'm a bit fast, ma'am. Is it able to cope up?
It's not like fasting, sir. It's okay. We can able to understand what you're told.
Fine. I'll share you the presentations, ma'am.
Sure, sir. It's very helpful, sir. The websites also, the link and all you can share, that will be very much helpful, sir.
Sure. I need to add that particular video. I'm not able to search it in a hurry. I'll just put it and find you and give you, ma'am.
Sure, sir. Sure, sir. Participants, is anyone having doubt? Okay, sir. Shall we wind up, sir? I think there is no worries.
Thank you for the opportunity, ma'am.
So really, it's a very good session, sir. It's very happy for this for attending this one, sir. Actually,
So
very
I'm humble, ma'am. I'm really humble, and we look for the 11th session, ma'am.
Yes, sir. We'll be having another session.
Thank you, and wishing everyone a good night. Thank you.
Yes, sir. Thank you, sir.